All right, here we are at chapter 4. This is the first section. This chapter is over graphing polynomial functions. And stay tuned for which sections we're skipping in this chapter, because I can't remember right off the top of my head, but I will definitely let you know in class so that you can put an X through those pages. We are skipping a couple of those sections. Okay, so first of all, we need to know what constitutes a polynomial function. Well, your book is going to tell you, it's going to give you this. Just note the exponents are in descending order. Like if this is 5, this would be 4, the next one would be 3, the next one would be 2, and it always ends with the constant. So for example, these are all the kind of, not all of them, these are some of the polynomial functions that have names. So on a linear function, the exponent is 1. On a quadratic function, the highest exponent is 2. On a cubic function, the highest exponent is 3. And on a quartic, the highest exponent is 4. This is a 4th degree polynomial function. This is a 3rd degree. This is a 2nd degree. This is a 1st degree. So the degree of the polynomial function is the exponent of the leading term. And we're going to talk about, well, let's just go ahead and do some examples. So on your worksheets, there's going to be a section that says identify the polynomial function, write it in standard form, and state its degree, its type, and the leading coefficient. So we're going to talk about what all those things mean. So the first example is f of x equals negative 2/3 x cubed plus 5x plus 8. Well, this is already in standard form, because standard form is you start with the term with the highest exponent, and then you write them all in descending order, always ending with the constant. Okay, so first of all, this is in standard form. The degree is 3. The type, because this is a 3, this is a cubic function. And the leading coefficient. The leading coefficient is whatever the coefficient is of the highest exponent term. The leading coefficient is negative 2. Okay, the second example I have here is negative 0.8 x to the x cubed plus the square root of 2x to the 4th minus 12. This is not in standard form, so I need to rewrite it. And this is the term that's going to have to come first because it has the highest exponent. So this would be written as the square root of 2x to the 4th minus 0.8 x to the 3rd minus 12. Now it's in standard form. The degree is 4. The type is, it's a 4th, or the exponent is 4, so I know it's a quartic. And the leading coefficient is the square root of 2. All right, let's look at the third example. H of x equals negative x squared plus x to the negative 1 plus 4x. So if you remember your exponent rules from Algebra 1, this term is really 7 over x. Because when you have a negative exponent, you rewrite it as the reciprocal of the base, which is 1 over x. Well, a polynomial function, first of all, does not have negative exponents. You can't have the x in the denominator, so this is not a polynomial function. So we can't talk about the degree. We can't talk about any of that. It's just not a polynomial function. Let's look at the fourth example. this is in standard form because that's the highest exponent and it's in descending order. The degree of this function is, oh wait, I missed this part. X also can't be in the exponent. So this is also not a polynomial function. Sorry about that, I didn't even see that. So the variable always has to be in the base with numerical exponents that are not negative. All right, continuing on with 4.1. We're really interested in what happens at the ends of these functions. In other words, end behaviors when x approaches positive infinity or when x approaches negative infinity. In other words, I want to know what happens when x gets really, really big and when x gets really, really small. So you're going to want to see if I can get this all in the same shot. You're going to want to pause it right there and just copy this down. And then once you've copied it, we're going to talk about how we write this and what this all means, okay? So this is how you read this. As the function approaches negative, or the function approaches negative infinity, which is down here, as x approaches negative infinity. So if you picture the xy axes, as x travels this way, y travels this way. So as x approaches negative infinity, so does y. And then on the other side, f of x, y, approaches positive infinity, just keep getting bigger and bigger as x approaches positive infinity. This is what happens. This is the end behavior of a polynomial function with odd degree and the leading coefficient is positive. For instance, 4x to the 5th plus 3x squared. It has an odd degree and the leading coefficient is positive. So what happens when it has an odd degree and the leading coefficient is negative? Well, you can see that it just reverses it, right? So for instance, this could be negative 2x cubed plus x squared minus x plus 1. This has an odd degree and the leading coefficient is negative. So in this case, f of x approaches positive infinity as x gets smaller, as x approaches negative infinity. F of x approaches negative infinity as x gets bigger. In other words, as x approaches positive infinity. I also have a little chart up on the whiteboard of end behaviors, but you're going to want this chart in your notes too, because there's going to be questions like this on the test. So then, if we have an even degree and the leading coefficient is positive, notice that there's the end result is the same, right? The function approaches positive infinity as x approaches negative infinity, and it approaches positive infinity as x gets bigger, as it approaches positive infinity. And then it's just the opposite if it has an even degree and the leading coefficient is negative. So for this one, for instance, this could be 2x to the 4th plus x squared minus 2. It has an even degree and the leading coefficient is positive. This one could be negative 3x to the 6th minus 4. It has an even degree, and the leading coefficient is negative. We're going to talk about, in class, we're going to talk about how to determine how many times this thing changes directions based on the degree of the function, but we're not ready for that section yet. All right, so let's just do one. Here is an example of the problems you're going to have on this worksheet. It says describe the x values for which f is, oh, I wrote the answer. I can't really cover that up. Where f is increasing. Okay, so I'm going to do all my increasing parts in orange. So remember, if I were a little bug traveling on this graph, I am increasing until that point right there. And that point right there is x equals -1. So it's increasing when I'm going from -infinity to -1. And then it's also increasing right here. So it's also, and this point is x equals 1. It's also increasing from 1 to positive infinity. And then this part in here is where the graph is decreasing. And that's when x is between -1 and 1. So x is in between here, and that's where it's decreasing. They're also going to ask you when the function is positive and when the function is negative. So let's look at, see if I can get another different color out of here. Let's look at the positives when the graph is positive. So the graph is going to be positive there. It's positive there, and it's positive there. In other words, when is y positive? When is the function y going to have a positive value? So you'll notice that between this interval right here, in other words, between -2 and 0, and then it's also going to be positive when x is greater than 2. So then if we look at, oh, I don't have another highlighter right in front of me. I have red. So it's negative right here, and it's negative in this interval. So we want to know, or we're going to state that the function is negative in between when x is -infinity up to this point right here where x is equal to -2. And then it's also negative when x is between 0, this should be 2, not 1. Okay, so that's pretty much the, you're going to need to know how to talk about the end behaviors, where it's increasing and decreasing, and then you're going to want to talk about when the function is positive and when it's negative. And this is how we want you to do those notations. And that's it for 4.1.